In this section, we will learn to perform a cable pulling calculation in Etap. So before approaching Etap, we should know the basics of cable pulling and the expected results. So people in the industry are much familiar with the process of cable pulling. So cable pulling literally means to pull the cable through a conduit. So if you are wondering why we should perform such calculations, because cable pulling is a delicate process as threading a needle. So in order to perform the correct cable pulling, we need to have the exact pulling tensions, otherwise we could damage the cable or get the cable jammed inside the conduit. So what is cable pulling? Cable pulling is the moving of lengths of cable from one place to another in order to install a connection of some type between the separate areas. And during the process of cable pulling, the engineer will have to consider different factors to compute the pulling tension so that the cable does not get stuck in the raceway or trench, or no damage occurred to the cable during the process. And we will go through some cable pulling terminologies. The cable clearance is the spacing between the cable and the conduit inner diameter. And the cable configurations. So for a 3 cable, there will be 2 configurations, which is the triangular and the cradle. So the type of the configuration selected will depend upon the percentage fill. So the percentage fill as shown here is given by this, which is the inside diameter of the conduit, and the dx is the 1.05 times the largest cable in the conduit. So if this value is less than 2.4, then we can use the triangular configuration, whereas if this value is greater than 2.4, then we use the cradle configuration. So basically what this means is, if the conduit diameter is larger, we could go for a cradled configuration, whereas if the conduit diameter is small, we could go for the triangular configuration. And another configuration is the diamond configuration. So this is for a 4 cable pulling 4 cables through a conduit, and here the d by dx ratio should be less than 3. And next is the weight correction factor. So the weight correction factor is a variable that adjusts the sidewall bearing pressure caused by uneven weight distribution of single cables in a multiple cable pull. So during the cable pulling, we will consider the case of the weight of every cable. So if we are doing multiple cable pulls, then we should adjust the weight, and that is given by the weight correction factor. So the relative position of the multiple cable in the conduit produces a greater than normal force between the cables and the conduit that would exist for a single cable. So this can be viewed as an effective increase in the weight of the cable, and this depends upon the configuration in the conduit. So having multiple cables in the conduit can create a greater force between the cables. So as a result, you could have to use the weight correction factor in order to adjust the calculations. And these are the equations for the weight correction factor for various configurations for the triangular and for the cradled, where d is the small d is the diameter of the cable, and the capital D is the diameter of the conduit. And the coefficient of friction. The coefficient of friction actually depends upon the conduit through which the cable pulling is done. So in practical applications, we would like to apply lubricants in bends so that the coefficient of friction through the bend can be reduced. And the jamming potential. So actually, in a cable pulling scenario, if the cable pulling tension is higher, then this would cause a greater sidewall bearing pressure, or if the pulling tension is too low, then it could result in a jamming potential, or it could cause the cable to jam. so there is a greater chance of getting the cable jammed if the pulling tension is lower. So we use the following formula to determine the likelihood of jamming. So inner diameter of the conductor of the raceway and the outer diameter of the individual conductors are given by the capital D and small d respectively. The constant 1.05 factor is a reflection of the fact that bends are usually oval in the sectional view. So if the value of the jamming potential is less than 2.5, then we do not have a jamming problem. And if it is less than 3 but greater than 2.8, then jamming is possible. And if it is greater than 3, then you don't have a jamming problem. Then we will look at the sidewall pressure. So the sidewall pressure, the final step in cable pulling process, is determining whether the pulling tensions will compromise the conductor's sidewall bearing pressure limit. When you pull a cable or an individual conductor through a raceway bend or through a sheave, the sidewall bearing pressure develops between the cable or the conductor wall and the bend of the sheave. As I have mentioned several times throughout this lecture, that the cable tension, the cable pulling tension, is dependent on the sidewall pressure as well as the jamming ratio or the case of jamming. So if you have too much tension on the cable, then this could affect the sidewall bearing pressure of the cable and the conduit and thereby damage the cable. And if we have very low tension on the cable, then this would potentially result in the jamming of the cable. So the cable pulling calculations are used to effectively optimize between these two tensions and get the cable pulled through the conduit without any damage to the conductor. So let me show you the sidewall bearing pressure over here. And over here we have a bend in the cable, and during the bend the cable will have a bending pressure over here. At this point the cable will be touching the inside of the conduit and there will be a pressure applied onto the conduit. If this pressure is greater than that of the rated value for this cable, then we would have the insulation damaged. And now we have all the basics of cable pulling calculations, and let us go to Etap to conduct a cable pulling calculation.